Hey team, welcome to part 3 of the abstract classes series. So in the first video, we reviewed polymorphism and set up a case for abstract classes. In the second video, we set up that case for abstract classes. And in this part, we're just going to do some review of what we learned and try to apply it to other scenarios just to test our knowledge. So be prepared to answer some questions. Here is the first question. Let's see, I want you to tell me what is going to happen in this class. Take a second, try to figure it out, record your answer. Okay, let's take a minute. I'll show you what's going on in this class. So we always start at main. Main says I'm going to create a new class of type M. I'm going to go into a new class, my class, and I'm going to call it M. And then I'm going to look into my class. Let's see. It does not have a constructor, so I can assume that everything's set up the way it needs to be. And then the function I'm going to call 12 and 25. So when we make that call, we've got, it takes 12 and it takes 25. And assuming that all of this is working properly, it's going to instantiate A and B and then print out the sum, which 12 and 25 together makes 37. So if everything was working properly, it would print 37. So A seems reasonable. But then we have these other options. Compilation error due to line 1. Okay. So line 1 says, oh, my class is abstract. Okay. That's not going to cause an error on its own. My class can totally be abstract if it wants to, even if it doesn't have abstract functions in it. But do you remember what the constraint on an abstract class is? Like an abstract class has made a promise to the genie, but it has not fulfilled that promise yet. And so it must be restricted. Its punishment is that it cannot be instantiated. So down here, when we try to instantiate it, I think this is where the error is. The error is here on line 2. We cannot compile this code, like this code won't compile. There's a compilation error. My guess is that we have C. So let's look at this code here. I have it in my Eclipse. And you can see here the error is indeed on line 2. So it's going to say, it's pretty small, so I'm not sure if you can read that, but the error that my IDE is giving me is cannot instantiate the type my class. If I try to run it, it's going to show that bigger. Cannot instantiate the type my class. So the answer here was that this code will cause an error, and it's going to cause an error on line 2. If my class wants to be abstract, that's totally fine. But in order to instantiate it, it needs to have a descendant that fulfills any promises that are made in my class. At this point, my class doesn't really make any promises except that it's abstract. So it's sort of preventing itself from being created. But any of its descendants would need to not be abstract in order to be instantiated. And that's just not the case here. Okay, let's look at the next example. So here is the next example. Take a second, read it, come up with an answer, and record it. What's going to happen? Okay, let's look into this code a little bit. Okay, so here we have the main method. So that's where we're going to start. And in that main method, we create a new example2 object. Example 2 is defined here. It extends test abstract, which looks like an abstract class here. And the abstract class has a promise function, an abstract function called display that needs to be implemented. So here we have it implemented inside test abstract. That looks good. So it does seem like test abstract, it is not, or example 2 here, it extends test abstract, but it fulfills all of the promises that test abstract made, the promises being the functions that are labeled as abstract. They're labeled abstract here, but not labeled abstract here. So that looks pretty well formed. Okay, sorry, my mouse scrolls from side to side when I touch things. Okay, so here in main, we create a new example 2. There's no constructor, but there's no constructor in test abstract either, so that should be fine. We say it equals new example 2, totally cool. We say t.display, and here we go into the display function, which exists. We say string n equals my name. We have a function for my name, and it says just return Beyonce. So it should say my name is Beyonce. It should compile and execute successfully. Let's see. Let's look at it in the code. Example 2 here. I'm going to run it. My name is Beyonce. This is well-formed code. It compiles and runs. Test abstract made a promise that the display function needs to be implemented by a descendant in order for that descendant to be instantiated. And here, example 2 is a descendant of test abstract. It fulfilled the promise of its ancestor, and therefore it is allowed to be instantiated. And so we're able to instantiate it, interact with it, and everything's fine. Awesome. So that's the end of example 2. Let's look at example 3. Okay, take a second, read this code, and then record your answer. Okay, let's start reading this code. All right, here we have an abstract class X, so X cannot be instantiated. We know that just by reading its declaration. We can also see, okay, it has a no-arg constructor that prints dog. So whenever an X is created, dog is going to be printed. And then we have another method here. This is a promise method. It's an abstract method. So any descendant of X, if it wants to be instantiated, it needs to fulfill this promise. Then we have class X, or class Y extends X. It also has a constructor, a no-arg constructor that prints cat. And it fulfills the promise that X made, so that's good. And when you call that abstract method, it's going to print cow. All right, so then we have this main class that is going to create a variable with a declared type of X and a dynamic type of Y. And on X, we're going to call abstract method, which is totally fine because X has abstract method declared, even if it's not defined. So this code should compile. It should work great. But now what is it going to print? If all we had to worry about was what the abstract method printed, that would be cow, then we know that it's going to be, it would be cow. But look, that's not one of our options. So let's look into what happens when we create a variable, or when we call the new Y constructor. So we know this is a function that's being called. We can see the function right here. What it does is it prints out cat. So there is a little bit more to it, but I want to show you that more to it on the code itself. So let's look at that here. I'm going to run it and we'll see what the output is. It is dog, cat, cow. So what you see here, when we call new y, this y is called. And the first line of any constructor, whether it's written or not, is going to call the super constructor. So inherently in here, there is a line super added. This is added by default. We don't need to do it. We don't need to write it ourselves because it is going to be called automatically for us. There's some magic in it, some syntactic sugar that allows us to avoid writing this. But it is there by default. So what that means is when we create a new y, when we go into the y function, even if it's not listed in the y constructor to call the super constructor right away, it's going to be called. So first line in the y constructor is a call to the x constructor because x is its direct descent or direct ancestor. So we go into x. X is going to print dog. Then we can move on to print cat. So that's what's going to happen at the end of the constructor. And then we call the abstract method, which prints cow. So I'm going to run it one more time since I added this super call here. It runs exactly the same way. It is just that I have typed it out now, but if I omit it, it's still, Java is going to add it there for us. It would not add it if we did not have a no-arg constructor defined. So if here we said int x, y is no longer acceptable, we would need to call super with some integer in order for our code to compile. But so long as you have a no-arg constructor in your parent class, Java is automatically going to make the super call for you within your constructor. So the solution to this is dog, cat, cow. All right, team. I hope that you have learned from this series of videos, and I will hopefully interact with you soon. Thanks.